Now we're going to look at solving or writing two-column proofs. We always start off with what's given to us, and we end with what we're trying to prove. What's given to us is angle 1 and angle 3 are congruent, so we've marked that on our figure here. And you always want to do that. If they don't mark it, you need to mark it. So if we look carefully, when we do a two-column proof, we need the left-hand side for all of our statements and the right-hand side for all of our reasons. We always start off with the first statement being what's given to us, and our reason for the first statement will always be given. So always start with what's given to you. That's the best way to start. If we know 1 and 3 are congruent, other things that we can state that angle EBA, which is this angle right here, is made up of two angles. It's made up of angle 3 and angle 2. Now remember, what we want in the end is EBA and DBC to be equal to each other. So we're starting out with what EBA is. EBA is angle 3 and angle 2. And the reason for this, because we have two small angles equaling a big angle, our reason for this would be angle addition postulate, which was a postulate we learned in the last chapter. You're going to have to know those. Because we're also finding DBC, the next thing we want to do is we want to state, because 3 and 1 are equal, we want to state that we can substitute in angle 1 for angle 3, so we've rewritten EBA as the measure of angle 1 plus the measure of angle 2. And the reason for that would be the substitution property. Because we know 1 and 3 are equal, we can substitute in angle 1 for angle 3. Our next step, we can state that DBC, which is this angle right here, that's made up of 1 and 2 as well. So if you look carefully, we have EBA is equal to 1 and 2, and angles 1 and 2 are equal to DBC. Our reason for angles 1 and 2 being equal to DBC, again, we have two small angles equaling a big angle, so that's the angle addition postulate. Now, look at the way that they've written this. They've written this in a particular order. They're saying the first thing, EBA, is equal to angle 1 and angle 2, which is the second thing. So the first thing's equal to the second thing. We then repeated angle 1 and 2 is equal to DBC. So the second thing is equal to the third thing. So first equal to second, second equal to third. That means that the first and the last are equal to each other, and we use the transitive property for this. So there's our first proof. This is very similar to the proof that we did in the last section as well. Alright, here's another proof. We're given that AC is equal to AB plus AB, and we want to prove that AB is equal to BC. So we're going to start on the next page, same picture. We can't really mark anything on the figure this time because it's just saying the two small ones are equal to each other. So again, our first step is to write the given, and so we write AC is equal to AB plus AB, and the reason is given. Next, we know that the two small segments equal the big one, so we can say AB plus BC is equal to AC. And if you notice, again, we've got AC is equal to AB plus AB. We've got AB plus BC is equal to AC. So our AC is our connector here. This is considered to be the transitive property as well. So we can either write this as AB plus BC equals AB plus AB, or as they've written it, AB plus AB equals AB plus BC. Again, we've used the transitive property here. Finally, if you notice, there's an AB on both sides, and we're trying to figure out if AB is equal to BC. So if we subtract out the AB on both sides, we get AB is equal to BC. And that's it for this short video. Thanks.